Okay, everyone. So I'm going to, so today is the very last class before the final for our class. I'm going to go over the review problems. So as you know, the exam is going to be tomorrow, May 5th, May 15th, between 8 a.m. and 10:30 a.m. And then you'll have 30 minutes to scan your work and send it to me. You should try to send it as a single file and trying to make sure that the whatever you send it to me is visible so I can grade it. So the instructions are here written, and I send this by email to you as well. Again, send them to one of these three emails. So write your answers in an organized way, show your work, box your answers. You can use a calculator, one two-sided sheet of handwritten notes, 8.5 times 11 inches. No other materials are allowed, and so in this I will have 10 problems on the exam, and each one will be worth 10 points. So it will be 100 points, and each problem will be worth 10 points. Okay, that's so that if you do just the easy problems, you will still get quite a bit of points. Okay, so I'm going to try to do some of these problems, and well, the complete solutions have been sent to you already. And if you have questions, you can interrupt and ask me anytime. Okay, so are there any questions so far? Okay. Jorge, do you want to turn off your mic just in case? And if you want, you can turn it on anytime later, so that if you have questions.
Yes, sir. I will.
Okay, great. Thank you. Okay, so I'm gonna start. So I'm gonna start from the very beginning. Okay, so I'll try to go at a reasonable speed. So hopefully, if you have questions, just let me know. So as I said, so the material will be the final will be comprehensive, so we'll cover everything. So the first several problems go over things which we did in the beginning of the semester. Okay, so problem one. Use the definition of the derivative to find f prime of x, where fx is equal to negative 3x squared plus 4x plus 5. So I'm just going to write the definition of the derivative. So here we have f prime of x is equal to the limit h going to 0 of fx plus h minus fx divided by h. Okay, so for this we're going to write down what is f of x plus h. So let's write it down. So the limit h going to 0 of this expression here. Oh, there is not enough space, so let me make this smaller. Okay, so I have so f of x plus h is going to be this expression here, but instead of x, I'm going to plug x plus h everywhere. So it's going to be negative 3 times x plus h squared plus 4 times x plus h plus 5. So that's my f of x plus h. Then I'm going to subtract f of x, right? So f of x is whatever's written here. So it's the formula, which is negative 3x squared plus 4x plus 5. So divided by h. Okay, so if I simplify this, it's going to be the following. So it's going to be equal to limit h going to 0 of negative 3 times x squared plus 2xh plus h squared, right? So that's just this part here, x plus h squared is x squared plus 2xh plus h squared. Then I have plus 4x plus 4h, that's this part here, I distributed 4. So then I have plus 5. So that's everything in the first blue parenthesis. And then I'm going to subtract the second parenthesis. So then I have a minus sign here. So then this minus here is going to become a plus. So I have plus 3x squared. Then this plus is going to become a minus. So I will have minus 4x. And then the plus of the 5 will become minus 5. So I have several cancellations here. So what's canceled? This 5 and this 5 is canceled. 4x here and 4x here is also canceled. And also the 3x squared here is canceled with 3x, negative 3x squared that I get from here. So I can just forget about this x squared here. So I'm just gonna do it like this. So this cancels that. So what's left then is this negative 3 together with this expression here and this 4h here. So I'm gonna write that this is equal to limit h going to 0. So I still have the terms left from the first parenthesis. So it's going to be negative 3 times 2xh plus, again, negative 3 times h squared. So those are this term here times that and times that, plus 4h here. And then I divide by h. So the whole thing becomes then limit h going to 0. So I have on the top negative 6xh minus 3h squared plus 4h divided by h. So then what cancels? What's left is limit h going to 0. So let's see. So in the first term, this h will cancel that h. So I will have negative 6x. Then I will have negative 3h squared divided by h. So that's negative 3h. And then I have plus 4. Because h is in the last term, cancel out, right? So the whole thing becomes the limit of this expression here as h goes to 0. So all I have to do is plug instead of h 0. So what I get is this is equal to the same expression, but instead of h I plug just 0. So I get negative 6x plus 4. And that's my answer. Okay. So so this is what we get using the definition. If we're not sure, we can check using our laws of differentials. So let me just do it separately here, right? So you don't have to do it, but this is for your convenience. So if I take the derivative of um, negative 3x squared plus 4x plus 5, right? So now, right, so if I do that, then using the laws of derivatives, I have that this is equal to negative 3 times 2x plus 4, because the derivative of x is 1 and derivative of 5 is 0, so the whole thing becomes negative 6x plus 4. Okay, so this is just to check that in fact we got the correct answer using the definition of the derivative. Okay, are there any questions? Okay, so for this problem we needed to remember what the definition of the derivative is. That's this limit. So then instead of f of x, we just plug fx plus h here, the first term, and then we subtract f of x, right? And then after simplifying, we get an expression on the top which just has 3 terms here, and then we divide by h, and then all that's left is this term here and this term here and this other term which goes to 0 when h goes to 0, so that disappears, and then we have just negative 6x plus 4. Okay, so problem 2, find the equation of the tangent line to the curve. You had a very similar problem in your midterm 2, so there is a little bit of a difference here, so I'll just indicate what's different here. As usual, we have that the equation of the tangent line is written like this: y minus y naught is equal to m times x minus x naught. That's the equation of a line. Now the line has to pass through the points 1, 1, so y0 is equal to 1, x0 is equal to 1, so we have y minus 1 is equal to m times x minus 1. So we only need to find the m, right? So we only need to find the slope. Okay, so let's find the slope. So to find the slope, so in this case I should write that the slope is equal to the derivative of y, right? So it's y prime at the point 1, right? Okay, so we're going to find y prime. So how do we find y prime? Well, see, we don't have a formula for y, so we have to use implicit differentiation. So we're going to write down this equation, which is 7x squared minus 5 times y squared is equal to 2xy. And then we're going to differentiate both sides. So we're going to do implicit differentiation. Okay, so how do I do implicit differentiation? I differentiate both sides with respect to x. So the first term here is going to be derivative of 7x squared minus, actually let me write it like this. So here I have to take the derivative and here I have to take the derivative. So here I will have derivative of 7x squared minus 5 times the derivative of y squared, right? And then 2 times xy prime. Okay, so the first term is of course 14x. The second one is like we did in the midterm, we have y squared, right? Y is a function of x, so the derivative of y squared is 2 times y prime, okay? So that's the chain rule together with the power rule. And then the second, on the other side, we have this x times y. Now y is a function of x, so when we do the product, differentiate the product of x and y, we have to use the product rule. So it's going to do x prime times y plus x times y prime. So let's simplify. So we're going to get 14x minus 10 times y prime, and that's equal to 2 times. Okay, so let me just write here that x prime is, of course, well, the derivative of x is 1. Okay, so I'm going to do 2 times y plus 2x times y prime. Okay, I just distributed the 2 into the parentheses here and also here. Okay, so that's how I got that, and I wrote that x prime is just 1, so I didn't write it down. So that's our expression for y prime. So this is our expression, and all we have to do is to solve for y prime. So for that, we only need to do is to plug 1 and 1 instead of x and y. So that's what I'm going to do. So I'm going to write 14 times 1 minus 10 times 1 times y prime is equal to 2 times 1 plus 2 times 1 times y prime. Okay? And if I simplify, I'm gonna, well, collect the constant terms on the left-hand side. So I'm gonna get 14 minus, this term here is gonna go to the other side. So it's going to be minus 2. And that's equal to, well, here I have what? On the left-hand side, I have 2y prime. So I'm gonna write that down, 2y prime. And then there is the other term, negative 10y prime, and that's going to go to the other side. So I'm going to add that to the right-hand side. Okay, so what I get is 12 is equal to 12y prime. So that means y prime is equal to 12 divided by 12, which is 1. Okay, so that's my y prime, which is also the same as m. So here, instead of m, I just have to write 1. So I have that my equation here is going to be, right? So my equation is this one here, y minus 1 equals, and instead of m, I plug 1. So it's going to be y minus 1 is equal to 1 times x minus 1. Okay, so then that means y minus 1 is equal to x minus 1, and you can leave it like this, or you just can write that y is equal to x, and that's your equation. Okay, so that's the equation of the tangent line to this function at that point. Okay, are there any questions? Okay, so one more time, what we did here, we have this equation here. It's not an explicit formula for y. So what we do is we write down that the equation of the tangent line is always of this form, and because it passes through the point 1, 1, we have to only find out the slope. And to find the slope, we use implicit differentiation. So we write down this equation and differentiate both sides. So if I do the differentiation on the left-hand side, well, I'm differentiating with respect to x. So this part is just the regular power rule. And here I have to use the power rule together with the chain rule. And on the other side, I have to use the product rule. So after I do that, I can find an expression in terms of y prime, x and y. And then all I have to do is plug from here, instead of x and y, I plug that x equals y, 1 and y equals 1. So after I do that, I can solve for y prime. So that gives me my slope. Okay. So next question is evaluate limits. So there's 3 problems here. I'm gonna choose 2 of them and to have 2 on the exam. So here the first one is evaluate these limits. So here we have an example where we have to, well, let's see what happens if I take, so if I plug 5 instead of x here, I'm gonna have a 0 in the denominator, right? And I'm going to have, well, let's see, 5 plus 4, so that's 9 right here. So square root of 9 is 3, so it's 3 minus 3 on the top, so that means I have 0 divided by 0, right? So it's an indeterminate, so of the type 0 over 0. So we have to simplify this, and the way to do that is to multiply and divide by the conjugate of the top, the part which has the square root. Okay, so I'm going to do that. So the x plus 4 square root minus 3 divided by x minus 5. So I'm going to multiply and divide by this expression here, but with a plus sign. Okay, and the reason I'm doing that is because now the top, let's remember this formula. It looks like a minus b times a plus b. So the whole thing is a squared minus b squared. So if I do that on the top, then it becomes much more manageable, because the top becomes square root of x plus 4 squared. So I get rid of the square root, minus 3 squared, right? So that's this. See, I have here a minus b, and then I have a plus b. So that is equal to, by that formula, a squared minus b squared. Okay, so then I can write in the denominator whatever I have, x minus 5 times square root x plus 4 plus 3. Okay, so I'm going to simplify this a little bit. Well, in the numerator, I'm going to have x plus 4 square root and then square. Well, the square root and the square cancel each other out. So what I'm going to have is x plus 4 on the top. So I'm going to get x plus 4, right? For the first term, for this term here, without the square root. And then I'm going to subtract 3 squared, which is minus 9, right? So then I have x minus 5 times this other expression, which is square root x plus 4 plus 3. So on the top, I have x plus 4 minus 9, which is the same thing as, well, this is equal to x minus 5. So what I have on the top, I have it on the bottom too. So I can cancel. So x minus 5 cancels x minus 5 on the top. So what I'm left with on the top is just 1. right? So I have that this is equal to, so this is equal to limit x going to 5, 1 divided by square root x plus 4 plus 3, which is equal to the limit. Well, I don't have to do limit anymore. All I have to do is plug 5 in here. So I'm going to get 1 divided by square root 5 plus 4 plus 3. Now 5 plus 4 is 9. Square root of 9 is 3. So I get that this is equal to 1 over square root of 9, 3 plus 3, which is 1 over 6. Okay, so that's my answer. Okay, so again, what I did here was just multiply and divide by the conjugate, and then so let me make this a little smaller. Okay, so and then just simplify the answer. Okay, so let's do the next problem. The next problem is, well, it's kind of maybe not clear, but again, if you plug -3 in the top and bottom, you get 0. So both the top and bottom are zeros in this situation. So we're going to have an indeterminate of type 0 over 0 again. So we have to simplify, and the way to simplify is to well, to find the roots here. So to decompose this into products of simple terms. So in this case, I'm going to have x squared plus 2x minus 3 is actually equal to x plus 3 times x minus 1, right? So if you multiply it out, you'll see that, well, it's what we have here, because 3 times -1 is -3, and then I have 3x and minus x, that's 2x. And in the denominator, I will have x plus 3, and then times x plus 6, right? So in order to get 18, I have to have 3 plus 3 times 6. So, well, I can then cancel x plus 3 in both of these things. So I get that this is equal to the limit x going to -3 of x minus 1 over x plus 6. So the whole thing becomes, now if I plug -3, both the numerator and denominator are fine. In fact, none of them are 0. So I get that the answer is -3 minus 1 divided by -3 plus 6. So it's -4 divided by 3. So it's just -4/3. Okay, so that's an easy problem. So the next problem is, so we have a situation where we have polynomials on the top and on the bottom, and we have to find the limit as x goes to infinity. And in these situations, if the degrees of the polynomials are the same, then what you get in the answer is the ratio of the leading coefficient. So it's going to be -2 divided by 5. So that will be your answer. But you still have to show some work, and the way you do it is you multiply and divide the top and bottom by x to the third. So I'm going to do that right here. So I'm gonna divide the top by x to the third. So I'm going to multiply by 1 over x to the third. And then the same thing in the denominator, I'm going to divide by x to the third. Okay, so if I do that, I'm going to get limit x going to infinity of, okay, so I have negative 2x to the third divided by x to the third. So that's going to be negative 2. Then I have 3x squared divided by x to the third. Let's write that down. 3x squared over x to the third. And then plus 7 divided by x to the third. And then the same thing in the denominator. I have 5 times x to the third over x to the third. So those cancel. Plus x over x to the third plus 2 over x to the third. So now all the terms here go to 0 here, except the negative 2 and negative 5, right? So this is because, actually, let me write it a little more detailed. So it's going to be minus 2 plus, well, 3x squared over x to the third gives you 3 divided by x, right? Then I have 7 divided by x to the third. 5 plus x divided by x to the third is 1 over x squared plus 2 over x to the third. So then all these terms here, these all terms, they go to 0. These go to 0 and these go to 0. So that means my answer is going to be negative 2 plus 0 plus 0 divided by 5 plus 0 plus 0. So your answer is negative 2/5. So it's equal to negative 2 divided by 5. Okay. So again, it's just what? It's just the ratio of the leading coefficients. So negative 2 divided by negative 5. So if you write the answer immediately, you'll get some points, but if you don't have complete solution, then some points will be deducted. Okay, so let's go to the next problem. So, and as I said, only 2 problems from this 3 type of problems will be on the exam. Okay, so find the derivatives of these functions. So also here, this will not be done. So I will not be doing an example like this in the final. So I'll do just this kind of 2 problems. So let's do number 1. Number 1 is a simple quotient rule. So we have to find the derivative of this function. So 5x plus 4 divided by 3x squared minus 2 prime. So that's going to be 5x plus 4 prime times 3x squared minus 2 minus 5x plus 4 times 3x squared minus 2 prime divided by 3x squared minus 2 squared. Okay, so that's the simple quotient rule. So 5x plus 4, the derivative of that is just 5. Then I have 3x squared minus 2. And then I have minus 5x plus 4 times 3x squared minus 2, and the derivative of that is 3 times 2x, so it's just 6x. Then denominator stays the same. Okay, so if I simplify, well, actually you don't have to simplify, you can just leave the answer like this. Okay, so you just use the quotient rule and that's all. So let me just remind you that the quotient rule was if you have u divided by v prime, then that's just u prime times v minus u times v prime divided by v squared. Okay, so next is this problem here. So it's 3 times here, and each of them is a power function. So we want to write it as a simple in a simpler form. So I'm going to rewrite this a little differently. So it's going to be 1 over 6 times x to power 3 plus 5 times, and then I have divided by x to power 3, so that means times x to power negative 3, right? If I have the denominator, then that's the same as negative power, and then minus 4 times, well, it's 1 over square root x, so it's 1 over x to power negative 1/2, well, sorry, 1 over x to power 1/2. So then, because it's the denominator, I can move it up and write it as x to power 1 negative 1/2. So it's going to be 1 over 6 times x to power 3 plus 5x to power negative 3 minus 4 times x to power negative 1/2. Okay, so that's my function, and I have to take the derivative of that. So that means, actually, I'll just do it right here. So I have f prime of x is equal to the derivative of what I have on the top. So it's going to 1 over 6 times 3x squared plus 5 times x to power negative 3 minus 1. And then I have minus 4 times x to negative 1/2 minus 1. So that's going to be 1 over 6 times, okay, so I can cancel the 3 and the 6. So that's going to give me 1/2, right? So 3 and this is going to give me 1/2. Sorry, just a second.
Look at my braids.
No, what's that? Okay, sorry about that. Okay, I won't close the door. So I will have oops, I will have a 2 here, so it's 1 over 2 x squared plus 5 times x to power negative 4 minus 4 times x to power negative 1/2 minus 1 is negative 3/2. Okay, and that's your answer. Okay, so that's the answer for this example. Are there any questions? Okay, if no, I'll go to the next one. Okay, so the next problem 5 is very similar to the problem that to the problems we've done for the second midterm. So let me skip that, and if there is we want to do that, we can come back to it at the end. The solution is available. I send it to you already. Okay, so number 6. Use the intermediate value theorem to show that this function has a 0 in negative 2, 1. So what does that mean? So intermediate value theorem was the following. So it was this, that if you have a function which is continuous, like in this example, here is it's a continuous function. And if you know that at one of the endpoints, so maybe I should write that down. So all you need to show, so need to show that f of -2 and f of 1 have different signs. So what does that mean? That means one of them is positive and the other one is negative. So if you show that, and because the function is continuous, that means at some point it has to be equal to 0. So all we have to do is to calculate what is f at one of the endpoints and what is f at the other point, and then you have to make sure that the numbers are different, okay? The signs are different. So one of them is positive, the other one is negative. So let's calculate that. So f of 1 in this example is equal to 1/2 times 1 to power 4 plus 5 times 1 to power 2 minus 6. So it's 1/2 times 1 plus 5 minus 6. So if you do it, this is 5.5 minus 6, so it's -1/2. Okay, so that's a negative number, right? So if f of 2 is positive, then we would be done, but f of -2. So f of -2 is 1/2 -2 to power 4 plus 5 times -2 to power 2 minus 6. So that's -1/2. And -2 to power 4 is the same as 2 to power 4 because the power here is an even number. So that's going to be 2 to power 4 is 16, right? Plus 5 times -2 squared, again that's the same as 2 squared, so it's going to be 4 minus 6. So all these numbers are such that it's clear that you have a positive answer. So well, let's just do it. So it's equal to 1/2 times 16 is 8 plus 20 minus 6. So the answer is 22, and that's a positive number. So you have that f of 1 is positive here, f of 1 is negative, and f of -2 is positive. So then you can write by, so these two together tell me that by the intermediate value theorem, f has a 0. F has a 0 in the interval -2. What was the interval? -2 and 1. Actually, let's write between and -2 and 1. Okay, so that's your answer. Okay, so that's all you have to do. Because the function is continuous, we have that the function has to have a 0 between -2 and 1. Are there any questions about this? It's a very easy problem. Okay, so next problem. Okay, so this number 7 is also very similar to one of the midterm problems. So it says the total cost of producing X unit of a product is given by this. So that's the cost function that's given to you. And what you have to find is find the actual cost of producing 20th unit. So that means you have to make the cost to calculate the cost difference. So it's of 21st and 20th, or no, 20th and 19th, right? So that will give you, and then you do the calculation. I'm not going to do that. And so that will give you a number. So that will be the cost of producing 20th unit. And then part B is use marginal analysis to estimate the cost of producing 20th unit. So that's the same thing as doing the finding the marginal cost. So first let's find the marginal cost. So that's going to be C prime of x. So that's the derivative of the cost. Which is just equal to 3 times 2x plus 8. Right? Because the derivative of 300 is 0, so it's just 6x plus 8. So that's the marginal cost. But we want to estimate the cost of producing 20th unit. So that's the marginal cost, but you have to plug instead of x 20 or 19, doesn't matter. I mean, both answers give you approximately how much it's going to cost to produce 20th unit. So we can do C of C prime of 20 or C prime of 19. Both of them would be good. So one of them gives you 6 times 20 plus 8. So it's 120 plus 8, so 128. And this other one is 6 times 19 plus 8. So that's going to be 122 if you do the calculation. So it's 6 less than 128, right? So 122. So both of those give you an approximation to the marginal cost of producing the 20th unit. And if you do the calculation in part A, I believe you're going to get 125, but you can just plug the numbers and find them out using a calculator, and I've done that. I think it's 125. Okay, so are there any questions about this problem? Okay, if not, I'm gonna do the next one. So find the intervals where f is increasing, decreasing, concave up, concave down, and find all the relative maxima and minima and the inflection points. So again, this is very similar to something we've done on the practice on the midterm. So I'm just going to go over that fast. So again, the first thing we have to do is find the critical points. So let's do the critical points. Okay, so for critical points, you need to find the derivative. And in this case, it's equal to derivative of 2x to the third plus 3x squared minus 12, which is equal to 6x squared plus 4x. And we have to set it equal to 0 and solve. So I'm gonna write that this is equal to, sorry about that. Actually, just a second, let me tell them that they can, so that they don't bother. Okay, so the derivative here is equal to, so we can factor a 2 here and an x. So I'm going to do that. So it's going to be, oh, I did something wrong here, sorry. this is wrong, right? So I'm going to add 3 times 2x, so it's again 6x. So I can factor 6 and then x, so it's going to be 6x times x plus 1. So only if I set this equal to 0, I get that x equals 0 or negative 1. Right? So those are my critical points. So I have two critical points, x equals 0 and x equals negative 1. Okay, so so now I have to find the intervals where the function is increasing or decreasing. So 0 and negative 1 give me the I can draw the line, right? So there is 0 here and negative 1, so that's negative 1 and 0. So I have three intervals here, this, this, and that, and I have to figure out what sign the function has in each of these intervals. So so I'm going to pick the points here, 1 here, so it's going to be the point 1 here, then negative 1/2 here, and negative 2 here. So I'm gonna take those points and calculate the derivative at those points. So f at 1, f prime at 1 is equal to what? So I'm gonna use this formula here, okay? So it's going to be 6 times 1 times 1 plus 1. So that's 6 times 2, that's positive. So so that means f is increasing in this interval here where 1 is, right? So 1 is here, so that is increasing everywhere there. So that's in 0 infinity. F prime of 1/2 is equal to 6 times, where is the formula? Here is the formula. 6 times negative 1/2, sorry, negative 1/2, right, times negative 1/2 plus 1. So that's 6 times negative 1/2, so that's negative 3, times negative 1/2 plus 1 is positive, so that's negative times positive, which is negative. So f is decreasing in this interval negative 1 to 0, and then f prime of negative 2 is 6 times negative 2 times negative 2 plus 1, which is what? Which is negative 12 times negative 1, which is a positive number, which is just 12, right? So f is increasing in negative infinity to negative 1. Okay, so that's the answer for that. So f is increasing in this interval, decreasing in this interval, and increasing there. So I could have written just the here it's positive, negative, positive. So that's the derivative. Okay, so we know the intervals where f is increasing and decreasing. Next, we're gonna do so where the function is concave up and down. Okay, so let me just do that. So for that, we need to find the second derivative. So the first derivative is given here, right? So the second derivative, I'm just going to write it down. So f double prime x is the derivative of 6x squared plus 6x. So that's 12x plus 6. And if I set it equal to 0, then I solve and I get that x is equal to negative 1/2. So that's my place where the second derivative is 0. And now if I do the number line for the second derivative, I have only one place where it's equal to 0. So this is f of double prime. So that's negative 1/2. And if I plug the numbers, I'm gonna take, well, it's if I take 1 or 0, I'm gonna get 6. So let's just write it down. So f double prime of 0, 0 is greater than negative 1/2, so it's equal to 12 times 0 plus 6, which is 6, so it's positive. And then I have, let's make it big, f double prime of negative 1/2, and that's going to be 12 times negative 1/2 plus 6, and that's negative 6, so that's less than 0. So that means that in this interval here, the function is, the second derivative is positive, and here it's negative, okay? So that means the second derivative changes its sign and goes from concave down to concave up. So I don't have much space, so I'm just gonna write it down here. Maybe I can make everything smaller. Okay, so let's do it like that. So what I get is that f is concave up in the interval negative 1/2 to infinity, and f is concave down in negative infinity to negative 1/2. Okay, so from here. Okay, so that's what we get. So that means in particular that negative 1/2 f has an inflection point at x equals negative 1/2. And why is that? That's because the it changes concavity, goes from concave down to concave up in around negative 1/2. Okay, so then the only thing we're left with is to find relative maxima and minima. So I'm not telling you which test to use here, so we're going to use the easy one, so the second derivative test. So let's plug numbers. So we have to figure out the critical points. We have two critical points, right? These two critical points, 0 and negative 1/2. So which one is a local maximum, which one is a local minimum. So so for that we calculate the second derivative at 0 and second derivative at negative 1. We kind of done that already, but let's just do it again. So if I calculate the second derivative at 0, so where is the second derivative? Here is the second derivative. Okay, so I'm gonna plug in there 0, so 12 times 0 plus, oh, we've done it here already. So plus 6, that's equal to 6. Okay, so we did both. So therefore, second derivative is positive. So we have that the function has a local maximum. F has a local, sorry, not maximum, but minimum, right? At x equals 0. And similarly, here we got that at -1, the second derivative is negative. So I'm not going to calculate that again. So that means f has a local maximum at x equals -1. Okay, so that's my answer. So okay, so it has, because the second derivative is, and then we can write this is by second derivative test, but I mean you don't have to. Okay, so we have the second derivative positive, that means that there is a local minimum. If the second derivative is negative, that means there is a local maximum. Okay, okay, so that's problem 8. Are there any questions? Okay, so we have 2 more problems. Problem 9 is the following. So we have okay, so let's read the problem. When the price of commodity in P dollars per unit, okay, so when the price of commodity is P dollars per unit, consumers demand X hundred units. So where price and demand are related by this equation. So I'm going to write that equation again. So I have that there is a relationship between the price and demand, and it's given by this equation. So the question is, how fast is X changing with respect to time when it's equal to 3? So the demand is 300 units, okay, of the product, and the price is $2 per unit, and it is increasing at the rate of $5 per month. So what does it mean? What do we know? So we know we have to find, so the question is, how fast is X changing? Well, that means find the rate of change of X. So find X prime, okay? But what is given? What's given is that X is equal to 3, price P is equal to $2 per unit, and the rate of increase of the price, right? So, and is increasing at the rate of $0.5 per month. So that means P prime is equal to 0.5. So, question is to find X prime if you're given X, P, and P prime. Okay, so this is an example of, again, implicit differentiation. So an application of implicit differentiation to a economics problem. Okay, so let's try to find. So we need to find X prime from here. So let's do that. So if we differentiate this implicitly, we're gonna get the following. We're gonna take the derivative of the left-hand side, and that's gonna be equal to the derivative of the right-hand side. Of course, the right-hand side is a constant, so the derivative is 0. So the left-hand side is, well, it's not a constant, so we have to differentiate. And now we're differentiating with respect to time, so it's not with respect to x. So we have to use chain rule. So the derivative of p to power 3 is going to be 3 times p squared times p prime minus, and for this is going to be x times p squared prime. So this is we have to use the product rule here. So let's use the product rule here. So it's going to be again 3 times p squared times p prime minus, so the product rule here is going to be, I'll write it in parentheses here, x prime times p squared plus x times p squared prime. And that's equal to 0. So the only thing we have to do now is to remember that the derivative of p squared is equal to 2p times p prime. Okay, so I'm going to write everything down now. It's going to be 3 times p squared times p prime minus x prime times p squared plus, minus x times 2p times p prime. That's equal to 0. Again, I cannot write that x prime is 1. X is a function of t, so when I'm taking the derivative, I'm taking the derivative with respect to time. Okay? Okay, so now all I have to do is plug all these numbers that are given to me. X equals 3, p equals 2, and p prime equals to 0.5 into this equation. And if I do that, that will immediately give me what is x prime. So let me just do that. So I'm going to get 3 times p is 2, so I get 2 squared, times p prime is 0.5, minus x prime times, again p is 2, so it's 2 squared, minus x is 3, times 2 times, again p is 2, times p prime is 0.5. That's equal to 0. So if I do the calculations, I'm gonna get 3 times so 4 times 0.5 is 2, minus x prime times 4 minus 3 times 2, again 6. Okay, 3 times 2. So I get that 4 times x. So if I solve for x prime form, I take that to the left, to the right hand side. So I'm going to get oh, I don't know why I have a minus here. I made a mistake here. It's plus, plus, plus. So there's pluses everywhere. Okay. Okay. So it's going to give me, so it's 6 and 6. So it's going to be, if I keep x prime 4 on this side and move this 6 and this 6 to the other side, I'm gonna get that x prime times 4 is equal to 12. 6 plus 6 is 12. So x prime, actually negative 12. So x prime is equal to negative 12 divided by 4, which is negative 3. Okay, and that's my answer. So if you want to interpret that in terms of uh, the demand, that means that uh, x is the number, the demand is decreasing by 300 units per month, okay, because x was given in hundreds of units. Okay, so again, so what we did here was to use implicit differentiation to find the derivative of x, right, from the formula like this. Okay, so so I'm going to go just and finish the last problem. Okay, so so let's do these ones. These are already compound interest, so that's the topic which we covered. That's the very last topic which we covered. So I'm going to go over these problems right now. Okay, and that will be the last problem. Okay, So we have the following situation. So you have an account which is compounded yearly, and the yearly interest is 8%. Okay, so the question is, how much money should be invested today? How much should you deposit in an account which is compounded yearly at a rate of 8%, so that after 30 years you have $100,000 on that account? Okay, so again, what's the formula here? So let me just remind you, the formula is the amount that you get after the a number of years is the principal multiplied by 1 plus r, that's the yearly rate, and then raised to number of years. Okay, so that's the formula that is used for compound interest, where when we're doing compounding once a year. So what's A? That's the amount that you have at the end. P is the principal, that's the amount that you have in the beginning. R is the yearly rate, that's 8% in this case, and T is the number of years. So I'm going to plug all these things and try to find what I need. So what is it that I want to find? How much money should be invested today? So that's the principal. That means how much should you invest right now? Okay, the deposit amount. So A is the eventual amount, so that gives you 100,000. Okay, P is what you need to find. Right now, the rate is 1 plus 8%, so it's going to be 8%. R is 8%, meaning it's 0.08, 8/100ths, and T is equal to the number of years, so that's 30 years. So all we need to find here is P. So P is equal to, let's just divide both sides by the this number here, and that will give you a P. So it's 100,000 divided by 1 plus 0.03, that's 1.038 to power 30. Okay, and then you can use a calculator to find out what that number is. And I have I think it's approximately 39 years or something. Oh no, so that's a number as the deposit, so I can calculate that. Okay, so just a second. So it's going to be 100,000 divided by 1.08 to power 30. Okay, so that's approximately $9,937. Okay, so or 38. Let's click on this. So that's the amount you have to invest today to have 100,000 in 30 years. If you have an account that's giving you 8% per year. Okay. So are there any questions about this problem? Okay, so then let's do the next one. So the next one is similar, but what we're using is an account which is compounded continuously, so the formula is different. So the formula in this case is going to be when you have continuous compounding, so the formula you're using is A equals, again, your initial deposit times E to power RT. Okay, so where E is this 2.78. Okay, so again, A is the amount you have at the end, P is the initial amount you invest, and R is the rate and yearly rate, and T is the number of years. So in this case, what the question is that the question is the following. So you invest $10,000 in an account which has an annual interest rate of 10%, right? So 100,000 in an account with an interest rate of 10%. If interest is compounded continuously, that means using this formula, when will the balance reach 100,000, 200,000, and 300,000? So we're investing 10,000 and we're gonna see when will the account reach 100,000, 200,000, and 300,000. Okay, so so let's use the formula. So we have A. Let's do the case of 100,000. So we have the eventual amount is 100,000. That's equal to principal is the initial amount is 10,000. And then you have to multiply by E to power R. So R in this case is 10%. So that's 0.1, right? So 10, or I should write maybe 10 divided by 100, which is equal to 0.1. Okay, so I'm going to write 0.1 times T. And T is the number of years. That's what we need to find. So to find T, well, what do we do? Right, so we have to find T in here. So I'm going to simplify this. So let's divide both sides by 10,000. So I'm going to get 100,000 divided by 10,000. It's equal to e to power 0.1 times T. Okay, and how do we solve problems like this? Well, before we do that, we can simplify and write that 100,000 over 10,000 is just 10, right? So 10 is equal to e to power 0.1 times T. How do we solve a problem like this? Well, we use logarithms. So if you remember, the power that I need to raise e to get 10 is the logarithm of 10 with base e, okay? So I'm going to take logarithm of both sides, and I'm going to take no logarithm with base e, which is called also natural logarithm. So, and it's written like this: natural logarithm of 10 is equal to natural logarithm of e to 0.1 t. Okay, so this thing here, natural logarithm and e, they essentially cancel each other out, and all you get is the power here. So this whole thing is equal to 0.1 t. So your t is equal to, so I divide both sides by 0.1, and I get that logarithm 10 divided by 0.1 is the time that I need to wait. Okay, so if I simplify, logarithm 10 over 0.1 is the same thing as multiplying by 10, so it's equal to 10 times logarithm 10. Okay, and that will be my answer. So if you calculate this, this is going to be, okay, so let me write it down. 10 times logarithm of 10, that's going to be approximately 23 years. Okay, so that's how much you have to wait to make 10,000 into 100,000. If you invest it, if you have an account which gives you 10% per year, and it's compounded continuously. Okay, so let me then do the other two examples as well. Okay, so now we have the formula. Just we need to see where would I put instead of 100,000, 200,000, and 300,000. Well, that's right here, right? So the only thing I need to change is instead of 100,000, I write 200,000 or 300,000. So that's if I do 200,000, then I'm going to divide both sides by this 10,000. So it's going to make a 20 or a 30 here. So that's this 10 here becomes 20 or 30. So I'm going to get, so let's do B and C. So for B, I'm gonna get t is equal to 10 times logarithm of 20. That's the amount you need to wait to get to 200,000. So, right, so any guesses what that is? So you had to wait 23 years to get to 100,000. Well, it turns out that in order to get to 200,000, you just need to wait 6 more years. Actually, 7, 20, approximately 30 years. And then for part C, which is the 300,000, you need to do just t equals 10 times logarithm of 30, and that's approximately, let me just do it like now. So that's approximately 34, so 34 years. So if you think about it, it's pretty amazing that you had to wait 23 years to make the first 100,000, but then after that you only had to wait 7 more years to go from 100 to 200,000, and then you have to wait only 4 more years to go from 200,000 to 300,000. And in fact, if you calculate more, you will see that to go from like 400 to 500, all you have to do is just wait 1 more year. Of course, overall it takes a long time, but then it starts accumulating very, very fast. Okay, so let me ask if there's any questions, especially about this last part. So do you guys have any questions? I saw, okay, so let's see. Jorge said, no, can you move the screen up? It is being blocked. Oh, I'm really sorry. Okay. Okay. Was that a long time ago or no? Okay. So well, the solution is posted online, and also I send you solutions. So this should be this should be the same thing to you. Okay, guys, I'm done. Do you guys have any questions? Okay, so I'm gonna stop recording.